In this video, we will be discussing multiplying radicals. So first of all, the product rule, to remind ourselves what that says, you can multiply radicals if they have the same index number. So if we take a look at this example right here, the index is that little number here. If they are the same, whatever is in the inside of the radical does not have to be the same, and we are allowed to multiply them. So 2 times 4 is 8, and now we have, so the index stays the same, so the cube root of 8, what times itself 3 times is 8, would be 2. So in this example over here, we cannot multiply these two because we have the square root of 2, the index here is 2, and the index here is 3. So in this example, we could not multiply. So to recap, in the previous videos, we learned how to add and subtract radicals. So when we're adding radicals, they have to have the same index number here and the same number inside the radical. So then this would be 1 radical 2 plus 1 radical 2, it would equal 2 radical 2. But if we add the square root of 2 plus the square root of 3, we can't simplify this because the inside of the radical, the radicand, does not match. But with multiplying, we can. As long as the index match, we can multiply and get the square root of 6. So again, when you're adding, these have to match. When you're multiplying, they do not have to match, and you are allowed to multiply them. So again, when it says to add or subtract, they have to match, and we are never actually adding the numbers inside the radical. So we did not add 2 plus 2 and get 4, we kept it the same. Just like we would with like terms. If we have 2x plus 5x, it's 7x. We don't do anything with the x part. So it's just like that when you're adding radicals. But when you're multiplying, they can be different. So let's go ahead and take a look at this example here. So when we are multiplying with radicals, we can do each radical individually, simplify if it's possible. In this problem, we cannot simplify them individually. So remember, we know if a radical is simplified, if none of these numbers can go into it, can divide into it. So then all we're left with that we can do is to do 2 times 6 since the index is the same. And then we always simplify our final answers. So since 4 goes into 12, we know that this could be simplified. So I can rewrite it as the square root of 4 times the square root of 3. And the square root of 4, what times itself is 4, is just 2. And we would get our final answer, 2 rad 3. Now remember, you could also simplify this by making a factor tree, picking any two numbers you want that multiply to 12. And then, I know it's kind of corny, but think of this like a jail. To escape, you have to have this many that match. So if there's no little number here, it's a 2. So this matches, but only 1 makes it out. And then we have the 3 left inside. So again, those are the 2 ways to simplify a radical. Now, if ever you're worried that you're going to forget when you're allowed to multiply or when you leave it the same, you have a calculator that you are allowed to use on exams. And if you check it, the square root of 2 times the square root of 6, and then you jot down what that decimal is, so it's about 3.46, and then if we type in our answer, 2 times the square root of 3, we can see that we get the same thing. So then we know that our answer is correct. Alright, let's take a look at another one here. So here we have 2 parentheses touching. That just means multiply. So we have the 3. So in other words, I could break this problem up to 3 times, because there's a 3 next to a radical. That means times. So this is not a cube root because it's not written really tiny right here. So this is 3 times radical 7. And then 2 parentheses touching means times, and then 2. And a 2 next to a radical means times. So it's just saying to multiply all 4 of those numbers. So We can multiply these two together because they have the same index. We can multiply the 3 and the 2 together just like normal, that's 6. And then we could do 7 times 8 is 56. Or you could simplify this first. So if you simplify this instead, when you simplify the square root of 8, you would get 2 rad 2. So you could simplify before multiplying these together. So if you go about doing that, you will still end up with the same answer. The nice thing about simplifying this first is now you don't have a large number in the radical. So I'm going to go ahead and continue with this, but you would get the same answer if you multiplied all of these here together. So in this problem, I'm going to make a factor tree. So 7 times 8 is 56. And then I'm going to continue the tree until we have all prime numbers. Again, we think of the radical like a jail. To escape, we need 2 that match, but only 1 makes it out. And then these 2 are left inside. However, there was already a 6 out in front here. So we have to, again, it's being multiplied. We know that because when there's not a plus or a minus, it always means multiply. So our final answer would be 12 radical 14. 12 times radical 14. And that's exactly what we would get here if we did 3 times 2 is 6, and then 6 times 2 is 12, and then we'd have 7 times 2 is 14. So same answer. Okay, let's go ahead and take a look at number 16 here. So we know we can multiply these because the index are the same. We could try to simplify them individually first, or we could go straight across. So we'd have the cube root, 4 times 2 is 8, and then when we multiply, so when we do 4x squared times 2x, from a previous chapter, we know that when we multiply, we add the exponent. That's how come we have x cubed inside here. And then the cube root of 8, what times itself 3 times is 8, that would be 2. And then 3 goes into 3 once, with no remainder left inside. So we would get 2x for our answer here. Okay, let's take a look at the next one here. So when we have a number in front of a parenthesis, so just like if we had this problem here that we are familiar with, we take whatever's in front of the parenthesis and we multiply. So we're doing 3 times 2x here, and then 3 times 4. So that's exactly what we're going to do here. We're going to do square root of 6 times 2. So if it helps you, write it out. Square root of 6 times 2. And then we have the square root of 6 times the square root of 3. So when we multiply square root of 6 by 2, we can't multiply these two numbers because one's in a radical, one's not. So this is not 6 times 2. This is some decimal number times 2. So that's why we're just going to leave it as 2 rad 6. So remember, to multiply, they have to have the same index. This does not even have an index. And then these two we can multiply because the index here are both square roots here. So we would get a positive 18. Square root of 18. Now there's an addition. So now we're adding. So now we have to remember, in order to add radicals, these have to be the same, which they're not. So to find out if they can be simplified together and added together, we have to make sure each term is completely simplified. So that means we have to see if any of these numbers can go into 6, and the answer is no. And 9 goes into 18, so we know this one can be simplified further. So I'm going to go ahead and simplify the square root of 18. It's 9 times 2. Square root of 9 is 3, and we would get 3 rad 2. So I'm going to take this out and put 3 rad 2. Okay, now to be able to add these, this has to match, which they do not, so this would be our final answer. You could also have this as your final answer.